Right, Matrix, let's sum up what we've done in the past lessons with the parabolas, the hyperbolas, and the exponentials, particularly the grade 11 type. Matrix, watch this. If you take a graph of y equals x plus 1 squared minus 4, it's different to this graph, y equals 2 over x minus 1 plus 2. And that's very different to a graph that says y equals, say, 2 to the x plus 2 and minus 4, let's say. Okay, this is a parabola. Now, what this tells us here is the axis of symmetry. So if you put it equal to 0 and solve for x, this is the x of the turning point. That guy here, the y is negative 4. That's the y of the turning point. So you've got a little turning point here of the parabola. Okay, it would be something like that. It's got an axis of symmetry, x equals minus 1, and a turning point there of minus 1, minus 4. Okay, you can get your y-intercept, x-intercept. That's very important. But also, if you took the graph y equals x squared, what you're doing, this tells us you're going to shift the x values by 1 left. Okay, left. This here tells us you're going to shift the y values by 4 down. In other words, here, for this guy, you're subtracting 1 from the x's, and here you are going to subtract 4 from the y's. Okay, now that's the thing with the parabola. When you take the hyperbola, this gives you this guy here, if you put it equal to 0, gives you a vertical asymptote. Okay, vertical asymptote, that dotted line that does that. This is a horizontal one, y equals 2. But what this tells us is that you're going to shift the x values 1 to the right. Okay, and this tells us the 2 says you shift the y values 1 or 2 in this case, 2 up. Okay, in other words, here you're adding 1, and here you're adding 2 to the x's. And you always work with the basic graph like that. You get the x's, and you use noughts, minus 1, 0, and 1, and you then work out the y values for those. And then you do these shifts then apply. In other words, you add 1 to the x's, and you basically add 2 to the y's. When you get the exponential graph, there's only one asymptote. That is the asymptote. It's horizontal. Okay, this tells us how to shift. So what we do is we shift. So we affect the x's by 2 to the left. Okay, because remember, when you put that equal to 0, you're getting minus 2. So you're 2 left for the x's, and the y values go 4 down. Okay, the y values go 4 down, and you have that. So please be aware of these different strategies in the thing. I think you can almost access these lessons, if you go to Facebook, you can actually, I think you can get hold of these lessons and just go through this again and again. Okay, now what I want to do is I want to take you back to one further example, one final thing. Okay, determine the equation. They give you an exponential graph. Look at it. Look at the picture there. They give you a point on it. They give you the horizontal asymptote, and you then ask to find the value of b and q. In other words, the equation. And very, very importantly, remember that y is equal to b to the x plus 1 plus q. The fx is always y. Okay, so what are we looking? What we do know as well in this thing, if you think about it here, you know that q is equal to minus 2. That number on the end there, that minus 2, is the asymptote, the horizontal. So you can plug in that value. Okay, now if we go to the next slide, we can then substitute the point into there. We've got our q, and remember x, this is so important. Remember your x is going to be, this is where minus 3 is, and 2 goes over there. Okay, and there we go. And we can then bring the minus 2 across and solve for b. Okay, and we've got 1 over b squared is equal to 4, cross multiply, get the LCD, and then b squared is 1 over 4. Now, the other important thing, Matrix, you'll remember from logs or exponential graphs, is that value of b can never be negative. Okay, there's always restrictions on it. I'll go through that in a minute. But what we can actually say is very simply this. If b squared is 4, you can say 4b squared is equal, you can do this. You can bring that across and get a difference of 2 squares if you like. Okay, that's one way of doing it. So then you get b is equal to minus a half, or b is equal to a half. Or what you can simply do from that stage is just go b is equal to plus minus a half. But now what's very important in this equation, if you look at it, you've got y is equal to b. We know I'm saying it's a half to the x plus 1 minus 2. That's the equation. That's the q and that's the b. Now, why don't we include the negative a half? Well, in the theory behind this thing, if you've got a little exponential graph, I'm just going to write that there. What that value is, it's going to be, and this is important, it can either be a fraction between 0 and 1, or it can be bigger 1. It cannot be, so you cannot be, a cannot be negative, nor can it be 0. Okay, it can't be negative or 0. So be aware of this kind of thing. But my thing with graphs, guys, listen to me. If you know what to do with you got x plus 1, x minus 1 in the parabolas, in the hyperbolas, exponentials. The parabolas, the x plus 1 in that thing would be the axis of symmetry, x is minus 1. In a hyperbola, it's an asymptote vertical, and in the exponential, it tells you where to go. And in all of the cases, if it's x plus 1, you shift to the left. If it's x minus 1, you shift to the right. And the number tagging on the end tells you the shift up and down. Guys, it's been great being with you. Master this stuff and stay with us on Matrix Uploaded for more wonderful mathematics in the weeks to come. It's been great being with you. See you around and catch you on Facebook tonight. See you soon.